Now time to take a look at what happens when we mix the idea of what we've done with absolute values and equalities and solve equations that involve both things, or solve inequalities, I'm sorry. So this is a simple inequality with an absolute value. It says the absolute value of x is greater than or equal to 3. Well, in order to think about how to come up with solutions to this inequality, we need to think back to what the definition of absolute value was. Remember, absolute value talked about the distance away from 0 on our number line. So in this case, it is literally saying that the distance away from x on my number line is greater than or equal to 3. Or the distance away from 0 on my number line is greater than or equal to 3. So there's lots of numbers that are more than 3 units away from 0 on a number line. So I'm going to find my 0 on my number line and make a scale here. 1, 2, 3, 4, 5, 6. Well, if I come out to 3, that is exactly 3 units away from 0. And I said greater than or equal to. So I know that that actual number satisfies this condition up here. And then all these numbers over here actually are greater than 3 units away from 0 on the number line. Now, when we solved absolute value equations earlier, we knew that we always had 2 solutions. And just like before when we had 2 solutions, we're going to have 2 different situations here, 2 different scenarios. So there's a lot of numbers over here that exist that are more than 3 units away from 0 on the number line. There's also a group of numbers on this side of the number line that are more than 3 units away from 0. So I'm going to put in my negative values. Remember, I'm talking distance. So if I come out to -3, that is 3 units away from 0 on the number line. So it satisfies my condition. I can plug -3 into this absolute value symbol, and it will equal 3. And remember, I've got an or equal to 3 here. And if I plug in any of these negative numbers on this side of -3, if I plug in -6, the absolute value of -6 is 6, and that's bigger than 3. So all the numbers to the left are smaller than -3 satisfy this condition too. So I have actually 2 areas on my number line that satisfy this condition. And remember before when we graphed inequalities and they looked like this? They were compound inequalities and they are connected with an or. And that's going to be important for the next sequence that we do. That when it was greater than, that's going to translate to an or. Now let's look at less than, and a less than example. That the distance away from 0 on a number line for my number is less than 6. Well, let's draw my number line. Let's explore here a little bit. I'm going to actually come out a little bit further than I had. Okay, so let's look at some of these values. If I plug in if I plug in 7, if I plug in 7, the absolute value of 7 is 7, and it is not smaller than 6. If I plug in the absolute value of 6, or if I plug in 6, the absolute value of 6 is 6. It's not smaller than 6. It's equal to 6. But I know these numbers on this side of 6, when I plug those in, like if I plug in 5, the absolute value of 5 is 5, and it is smaller than 6. So I can get really, really close to 6 without grabbing 6. So I'm going to use an open circle, which should make sense because I have that or equal to sign. And I've got all these numbers in here that are less than 6 units away from 0 on the number line. And I can come all the way over until I get to -6. And I'm going to stop there because all of these numbers within that interval are less than 6 units away from 0 on the number line. If I get farther to the left of -6, if I grab -7, -7 is not less than 6 units away from 0. And if I plug in -7 into my absolute value inequality, it won't make sense. The absolute value of -7 is 7, and 7 is not less than 6. So I know this won't be a solution. So in less than inequalities, when dealing with absolute values, I get an interval. And remember, intervals were associated with our and compound inequalities. So a less than, when paired with an absolute value, is going to translate into an and kind of compound inequality. And we'll talk more about that in a little bit.